Hi everyone, welcome back to my channel. You are watching Education to All. Myself, Vinod. Today I am going to explain about real numbers exercise 1.2 question number 1. Prove that root 5 is irrational number. So this question can be proved by contradiction method. So step by step I will explain. Please concentrate carefully. So now let us assume root 5 is rational. If it rational can be expressed as p by q form, so right, root 5 I'm considering as p by q, where p and q are integers and co-primes. Now apply squaring on both sides. Apply squaring on both sides. By squaring on both sides, you get root 5 whole square is equal to p by q whole square. Then the square root 2 cancel and we'll get in LHS 5 is equal to RHS p square by q square. Now cross multiply both and it will get it as 5q square is equal to p square. If so, from this we can conclude that 5 divide p square as well as p. So write that 5 divides p square and p also. If it is dividing, I can say that 5 is a factor for p. So 5 is factor for p. So make it as equation number 1. If it is a factor, we can consider as in terms of 5. P in terms of 5. So I'll take it as p is equal to 5 times of small a, and this will replace in the above condition. What will happen? You observe carefully. We know 5q square is equal to p square. Now I'll replace this p value in the given equation. 5a whole square. So we expand it. 5q square is equal to 25a square. Now I can say that this 5 table in 25, 5 times cancel. Q square is equal to 5a square. And we can repeat the same previous statement here itself. Before we got 5q square is equal to p square. Now we got q square is equal to 5 times of a square. So here I can say 5 divides q square as well q also. If it is dividing, can I say it's a factor? Definitely. So 5 is a factor for q. So it's equation number 2. Observe equation number 1 and 2 carefully. 5 is a factor for p, 5 is a factor for q also. So can I conclude from equation 1 and 2 both having 5 is common factor? Yes, that's one. So now from equation 1 and 2, 5 is common factor for p and q. It means that p and q are not co-primes, na? It having a common factor is 5. Therefore, our assumption is wrong and it contradict the fact. It contradict the fact that what is the fact actually? Root 5 is irrational. I can conclude that therefore root 5 is irrational. It is a correct statement actually. Got it? I hope you understand. Similarly, we try to solve the second question. Prove that 3 plus 2 root 5 is an irrational number. So first what we do, let us assume let us assume 3 plus 2 root 5 is rational. Then 3 plus 2 root 5 is equal to p by q. And we know where p and q are integers and co-primes. Now you take the rational numbers to the opposite side. So what is rational number? 3 is a rational number. So then 2 root 5 is equal to p by q, and plus 3 sending to opposite side is minus 3. 2 root 5 is equal to, taking LCM as q. So this q cancel, p will come, and here it is 1 cancel in q times, so 3q will come. Is there any rational number still pending in the left hand side? Absolutely true. This 2 is there. Now the 2 is also sending to opposite side. Then root 5 is equal to p minus 3q is divided by 2 will go opposite side now, 2q. Now observe the RHS. P minus 3q by 2q is an RHS. Now write it. For any values of p and q, we can say that integral values of p and q, RHS shows that what type of number? Rational number. If it is a rational, can I say its root 5 is also rational? Then root 5 is also rational. But it contradicts the fact, so our assumption is wrong. It contradicts the fact that root 5 is irrational. So we can say that our assumption is wrong. Is wrong. And what we can do? We can conclude root 5 is irrational. If addition with irrational number with rational number are also irrational. So 3 plus 2 root 5 is also irrational. Got it? So next question. Now question number 3, Roman number 1. 1 by root 2, we have to prove it as irrational. So what we do? Let us assume 1 by root 2 is rational. If it is rational, we can conclude that it can be expressed as p by q. 1 by root 2 is equal to p by q. Always this statement should be right, where p and q are integers and co-primes. So next, no need to squaring on both sides, nothing to do. So cross multiply itself. By cross multiplication, 1 into q is equal to root 2 into p, and you cross multiply again, q by p is equal to root 2. This statement is very important. In LHS you observe that p and q is having numerator and denominator. So for any integral values for p and q, LHS shows that p by q, LHS shows that is rational, then root 2 is also rational. But it contradicts the fact, but it contradicts the fact that root 2 is irrational. So I can say that our assumption is wrong. I can conclude that root 2 is irrational. If root 2 is irrational, 1 by root 2 is also irrational. Got it? Root 5. Statement 1. Let us assume 7 root 5 is rational. Then I can express 7 root 5 is equal to p by q, and where p and q are integers and co-primes. Got it? Now this rational number I'm sending to the opposite side. Root 5 is equal to p by q, and it is multiplying, sending to opposite side, it divides 1 by 7. Then it leads to root 5 is equal to p into 1 is p, and 7 into q is 7q. It is very important to understand. So for any values of this RHS, what happens? It's rational. So integral values for p and q, RHS shows that p by 7q is RHS, actually shows that rational. It is showing the rational. Can I say that then root 5 becomes rational? Then actually it contradict the fact. It contradict the fact that root 5 is irrational. So our assumption is wrong. Therefore I can conclude that root 5 is irrational. Then if root 5 is irrational, irrational number is multiplied to rational number also becomes irrational. So 7 root 5 is also irrational. Got it? Now Roman number 3. So it is 6 plus root 2. How to prove it? So first let us assume 6 plus root 2 is rational. If it is rational, can be expressed as p by q. So 6 plus root 2 is equal to p by q, where p and q are integers and co-primes. Now 6 sending to the opposite side, that is rational number sending to opposite side. So root 2 is equal to 6 by q minus p, 6, and taking LCM, q will be the LCM. So this q cancel, so p is alone there. Denominator is 1 for 9, 6, 1 for 6. Here denominator 1 for 6, so this 1 in q times cancel, 6q. Now observe this data carefully. In RHS it is rational number only, so write this statement. For any integral values for p and q, RHS, that is RHS p minus 6q by q shows that rational. then root 2 is also rational. Actually, it contradicts the fact. It contradicts the fact. What is the fact? Root 2 is irrational. Then our assumption is wrong. Our assumption is wrong. What is our assumption? Root 2 is rational. Therefore, root 2 is irrational. If root 2 is irrational, can I conclude that 6 plus root 2 is also irrational? That implies 6 plus root 2 is also irrational. Got it? Like, please subscribe my channel. Thank you. Have a nice day.